How's it going, ladies and gentlemen? Mr. Johnny here once again, taking a look at 25.2 stuff, hydrocarbons. So our objectives are to classify hydrocarbons into alkanes, alkenes, alkynes, and aromatics. So we want to know what the difference between those are and, what they look like. So some vocabulary that you need to know right off the bat. We have hydrocarbons, which is basically, it just means it's made of only hydrogen and carbon, right? Probably blowing your mind here. Hydrocarbons, you got hydrogen and carbon, right? Hydrocarbons. Then we have this term saturated, which basically just means contains the largest possible number of hydrogens per carbon atom. It's full of hydrogen. It's saturated with hydrogen. You can't add any more hydrogens to that carbon chain, right? And then we have unsaturated, which means the opposite. It contains less than the largest possible number of hydrogens per carbon. It could hold more hydrogens. You can add more hydrogens. There's still more room. It's not maxed out with hydrogens. That's unsaturated. All right, so different types of hydrocarbons. We can have alkanes, alkenes, alkynes, and aromatics. So relating back to that vocab, these are all unsaturated. And then our alkanes are going to be our saturated hydrocarbons. And you'll see what that means in a second. So alkanes have a generic formula of C to the N. So N is just the number of carbons. H to twice that number of carbons plus 2. So if I take a look at this example right here, I have 4 carbons, so C4. And I count all the hydrogens, and I have H10. So, well, if N is 4, then 2N plus 2 will be 2 times 4 plus 2 equals 10. So I know if I have 4 carbons and 10 hydrogens, then I have a saturated hydrocarbon. So basically, alkane, there's only single bonds between carbons. If there's a double bond or a triple bond, then it's not an alkane. Just single bonds between carbons, you got an alkane. So alkane, if it ends in ane, you have a single bond. All right, so this is considered saturated because you can't add any more hydrogens to it. All these carbons are full. They made their complete octet. You can't make them hold any more hydrogens. They're all single bonds. You can't do anything, all right? So they're saturated. Alkenes have the generic formula of CnH2n. So if I had C4, how many hydrogens would I have in an alkene? Well, 8, right? So you see it should be able to hold 10, but it doesn't because it's unsaturated. So alkenes contain a carbon-carbon double bond. So you're looking for this right here. So carbon-carbon double bond makes it an alkene. So ene, there is a double bond. This is unsaturated because what you could do is you could break one of those double bonds and then those carbons could bond to more hydrogens. But they didn't. So they are unsaturated. All right. And that's an alkene. Alkynes is a triple bond. You're looking for a carbon-carbon triple bond. So if you had that, you have an alkyne. And the generic formula is going to be CnH to the 2n minus 2. So again, if I had C4, how many H's would I have? 6. Because it'd be 2n, so it'd be 8 minus 2 gives me 6. So if you have that generic formula, then you know you have an alkyne. Why is it considered unsaturated? Because what you could do is you go, hey, let me break one of those multiple bonds and have each carbon bond to more hydrogen. And hey, I could even do that twice. And then you would have a saturated hydrocarbon. But that triple bond means that it's not saturated, it's unsaturated. And then you have aromatics, some of my favorite. So aromatics are really cool. Basically, carbon atoms are connected together to make a planar or a flat ring using single and double bonds. So what happens is each one of these carbons is trigonal planar in its geometry, and you end up with literally a flat molecule. And what's really cool about these molecules is that there's resonance. So you may be saying, hey, why is the double bond here and not here? Well, if you can ask that, then you have resonance. So basically, instead of having them where those are, like let me draw the resonance structure. So you go, hey, the double bond was on the left side here. Now it's going to be on the right side, and it alternates where the double bond is, and then each one of these carbons has a hydrogen on it. And what's really cool about this is whenever you have resonance, you have delocalized electrons. So these electrons aren't just stuck in between this carbon. They're actually shared between this carbon too, right? Because you have resonance structures. So Another way to draw this molecule being benzene is just to go, hey, because those electrons are delocalized around the whole thing, you just draw a circle, and that's benzene. Aromatics are pretty cool because they're really stable, they're flat. I think they're cool. They're one of my favorites, right? So to summarize, what can you say about the similarities and differences between alkanes, alkenes, alkynes, and aromatic hydrocarbons? And that's pretty much it. Hope we found this helpful. We'll see you in class. Goodbye.